Ever wondered how your data knows exactly where to go in an Ethernet network? The answer lies in a frame tagging method known as .1Q1. This clever system allows for the division of an Ethernet network into multiple virtual local area networks or VLANs. By doing this, it can isolate traffic from different parts of the network, improving both security and performance. But how does .1Q1 work? In essence, when a frame of data is sent on an Ethernet network, it's encapsulated with a .1Q tag. This tag carries the VLAN ID of the frame. Much like a postman reading a zip code to determine where to deliver a letter, when the frame reaches a switch, the switch examines the tag to figure out which VLAN the frame belongs to. The switch then dutifully forwards the frame to the ports associated with that particular VLAN. To delve a little deeper, the process involves 4 key steps. First, you identify the traffic you want to isolate. Then you create VLANs, essentially isolated mini-networks within your larger network, each with its own unique VLAN ID. The third step involves configuring your network devices to tag frames with the correct VLAN ID. This includes switches, routers, and any other devices that can forward traffic on the network. Finally, you assign devices to the appropriate VLANs. This can be done either manually or automatically. The benefits of .1Q1 are manifold. It strengthens security by preventing unauthorized access to sensitive data. It enhances performance by reducing the amount of traffic that needs to be processed by network devices. It simplifies network management, making it easier for administrators to manage the network and troubleshoot problems. And importantly, it supports multicasting, a technology that allows a single packet to be sent to multiple destinations simultaneously. To sum up, .1Q1 is like the zip code for data on an Ethernet network. By isolating traffic and simplifying network management, it improves security, boosts performance, and supports multicasting. So the next time you send a file or stream a video, remember the hardworking .1Q1 guiding your data to its destination. .1Q1 isn't just for data centers. It's also a vital tool for isolating traffic on customer premises equipment. By segregating different types of data, it can significantly improve security and performance. For instance, in telco networks, .1Q1 is often used to segregate voice and data traffic, guest and employee traffic, or even broadcast traffic. And it's not just a theoretical advantage. Major telecommunication providers like AT&T, Verizon, and T-Mobile have implemented .1Q1 in their networks, reaping the benefits of enhanced security and performance. So, the next time you're on a call or streaming a video, remember it's .1Q1 working behind the scenes, ensuring your data gets where it needs to go, safely and efficiently. Moving on from theory to practice, let's delve into a detailed project plan on how to implement .1Q1 in a telecom network. The objective of this project is to enhance the security and performance of the network by segregating different types of data with .1Q1. The project scope involves implementing .1Q1 on the access network of this telecom network. The project will be divided into 3 phases: planning, implementation, and deployment. The planning phase will involve network analysis, designing the .1Q1 structure, and creating a detailed implementation plan. The implementation phase will involve setting up the .1Q1 on the network devices, followed by thorough testing. Lastly, the deployment phase will involve launching the .1Q1 into the network and monitoring for any issues. As with any project, there are potential risks involved. These could include network downtime during implementation or potential security vulnerabilities. However, we have robust mitigation strategies in place, including backup plans and security audits. The success of the project will be evaluated based on a few key criteria. This includes the successful segregation of different data types, improved network performance, and enhanced security. By the end of this project, we aim to provide a more secure and reliable network for the telecom company, benefiting both the company and its customers. Voiceover. As we move on from the project plan, let's take a moment to appreciate the practical impact of 802.1Q in telecommunications networks. This protocol is being used increasingly across the globe in various parts of the network, from core networks to access networks, and even in customer premises equipment. The benefits are multifaceted and significant. Firstly, 802.1Q enhances security by segregating different types of data, ensuring the integrity and confidentiality of each data stream. Secondly, it improves network performance by reducing congestion and enabling smoother data transmission. Thirdly, it simplifies network management, making it easier for network administrators to monitor and control the network. And lastly, it supports multicasting, which is crucial for services like IPTV and video conferencing. In conclusion, 802.1q has proven to be a valuable tool in the telecommunications industry. It's not just about theory, but about practical, tangible improvements to the security, performance, and manageability of telco networks.